In this video, we're going to take a very careful look at an example of a power series, and we're going to find all the values of x for which that power series is convergent. And this is something that is very, very important. So let's take a look at this one. We want to find all the values of x such that the series given by the sum from n equals 0 to infinity of x to the n over n times 2 to the n converges. Okay. One of the best tools we have for studying power series is the ratio test, so that is what I'm going to do. We're going to use the ratio test with an equals x to the n over n times 2 to the n. So we have to look at the absolute value of an plus 1 over an, and is this big chunky expression. Just take a moment to just look at it. And now after massaging it and make it a bit more manageable, we end up that this is n times 2 to the n over n plus 1 times 2 to the n plus 1. And then we have the ratio of the absolute value of x to the n plus 1 over absolute value of x to the n. So there is quite a bit of simplification going on. So 2 to the n over 2 to the n plus 1 will end up being just 1/2. Absolute value of x to the n plus 1 over absolute value of x to the n is just absolute value of x. So after doing some simplifications, we end up with this. We have 1/2 times n over n plus 1 times the absolute value of x. Now, as n goes to infinity, what can I say about n over n plus 1? Well, that is just 1. So the limit as n approaches infinity of the absolute value of an plus 1 over an is just the absolute value of x over 2. I'm going to call this limit L, just to make it a bit easier to talk about it. Okay, so we have this, and the ratio test tells me that if this limit L is less than 1, my series is absolutely convergent and therefore convergent. If this limit is strictly greater than 1, then my series is divergent, and then we'll have to figure out what to do when L equals 1. So let's take a look at this. If the absolute value of x is less than 2, then L, which is the absolute value of x over 2, is strictly less than 1. And that tells me by the ratio test that the series converges absolutely. If the absolute value of x is strictly greater than 2, then L, which is the absolute value of x over 2, is going to be strictly greater than 1, and the ratio test tells me that my series diverges. Okay, what happens when the absolute value of x is equal to 2? Well, the limit, which is absolute value of x over 2, is going to be just 1. And that's a problem because the ratio test is inconclusive. It's a bit annoying, but, well, we just need to do something else. So, what is that something else that we're going to do? Well, let's take a look. If x is equal to 2, well, I will just plug in x equals 2 into my power series and see what I get. Well, when I plug it in, I end up with the sum from n equals 0 to infinity of 2 to the n over n times 2 to the n. So the 2 to the n cancel, and we end up with the sum from n equals 0 to infinity of 1 over n. Does it look familiar? I hope it does. That is just the harmonic series. So the series diverges, right? This is just a harmonic series, as I said. Okay, and now we said the problem is when the absolute value of x is equal to 2. That means that x could be 2, right? But x could also be, yeah, I'm sure you said it, negative 2. So, if x is equal to negative 2, again, I'm going to plug in that value into my power series. I end up with the sum from n equals 0 to infinity of negative 2 to the n over n 2 to the n. Well, negative 2 to the n is the same thing as negative 1 to the n times 2 to the n. So, then we're going to end up with the sum from n equals 0 to infinity of negative 1 to the n over n. And this one has to look familiar, right? Yes, you're correct. This is the alternating harmonic series. And we know that this series converges. So we have that for x equals 2, my power series diverges. For x equals negative 2, my power series converges. So now I just need to put all the pieces together. Well, we saw that if the absolute value of x is less than 2, my series is absolutely convergent and therefore convergent. I know that if x is equal to -2, my series is convergent, and in all the other cases, my series was divergent. So we know then that the series converges for x that is greater than or equal to -2 and strictly less than 2.